Hello and hi everyone. We are a team of junior chemists from the chemistry department. Today we will present our analysis for the assigned parts related to chromatography separation, reverse phase HPLC and STIR spectra interpretation. Throughout the presentation, we will highlight the key concepts such as the number of theoretical plates, peak resolution, polarity and functional group identification. I am Khairunisa and my teammates are Nur Shafiqah, Nabila Murshida and Ryan Wong Zi.
Let's begin with task 1, where we analyze the efficiency of two chromatographic columns for separating component B. The number of theoretical plates N is calculated using the formula N equal to 16 times open bracket retention time over peak width close bracket square. For column 1, N is equal to 16 times open bracket 10 over 2 close bracket square equal to 1111.1. And for column 2, N is equal to 16 times open bracket 10 over 2.2 close bracket square equal to 330.6. Since column 1 has a higher N, it is more efficient for component B. Next, we calculated the peak resolution RS. RS is equal to 2 times retention time for component B minus retention time for component A over peak width for component A plus peak width for component B. Substituting the values, RS is equal to 2 times 10.0 minus 8.0 over 1.0 plus 1.2 equal to 1.82. Since RS is more than 1.5, the baseline resolution is achieved. Therefore, the separation is effective.
In this task 2, I will explain the elution order of three compounds in a reverse phase HPLC experiment using a C18 column. In reverse phase HPLC, the stationary phase is non-polar and the mobile phase is polar. This means that the polar compound which interact less with non-polar stationary phase elute first, while non-polar compound which interact more strongly elute last. The three compounds we are analyzing in this task are methoxybenzene, which is compound 1, benzene, which is compound 2, and nitrobenzene, which is compound 3. Methoxybenzene with its OCH3 group is moderately polar. Benzene is non-polar as it lacks any polar functional group, and nitrobenzene with its NO2 group is highly polar. Based on their polarity, compound 3, which is NO2, will elute first, followed by compound 1, OCH3, and lastly compound 2, which is benzene. Therefore, the elution order is 3, 1, 2. Looking at the chromatogram, the first peak corresponds to compound 3, the second peak compound 1, and the third peak to compound 2. The distinct separation of peak indicates good resolution and efficient column performance. In summary, the elution order is determined by the compound's polarity with the order being 3, 1, 2. This reflects the fundamental principle of reverse phase HPLC and highlight its effectiveness in separating and identifying compound.
Hello everyone, today we'll be interpreting the functional groups identified in the Fourier transform infrared spectra of two given chemical structures. Let's dive into the first spectrum. In the first spectrum, which corresponds to a cis-2 octane, we observe three absorption peaks. The first is at 3023, which indicates the presence of an alkane group, specifically with double bond C, single bond H stretching vibrations. Next, between 2800 and 2900, we see absorption due to alkane group. This corresponds to the CH2,4 CH3 portion of the molecule, representing the long hydrocarbon chain. Lastly, at 1660, there is a strong absorption band attributed to the C to C double bond, which confirms the presence of the alkene functional group in the structure of cis-2 octane.
For the second spectrum, which corresponds to butyramide, we can see some key peaks that reveal its functional group. First, there's a broad peak between 3219 and 3500 cm mice. This is a clear sign of the NH2 group, which is part of the amide structure, RC double bond O NH2. Next, we see a peak between 3800 and 3900 cm mice. This tells us there's an alkane group, specifically CH2 through CH3 in the molecule. Finally, the sharp peak at 1650 cm mice is from the C double bond O bond stretching. This confirms that amide group are C double bond O NH2. So, to summarize, the FTIR spectrum of butyramide shows the functional group NH2, C double bond O, and alkane, which match its chemical structure perfectly. To summarize, our analysis has provided clear insights into the given task. For task 1, we demonstrate that column 1 is more efficient for separating component B, achieving baseline resolution with RS more than 1.5. In task 2, we predicted the elution order in reverse phase HPLC as 3, 1, 2 based on the compound's polarity and their interaction with the C18 stationary phase. Finally, for task 3, we successfully interpreted the FTIR spectra to identify functional group, confirming the structural characteristic of the compound. This result highlights the importance of combining theoretical calculation and spectroscopic techniques for precise chemical analysis.